Okay, so good evening, all, and welcome back to the session. So, friends, in our previous session or previous couple of sessions, what we have discussed, uh, we have created a tool calling LLM. Okay, we have seen it. We have created a particular tool, and which was utilized in order to perform a particular task. And as and when required, the LLM is going to utilize that particular tool in order to perform the action. Okay, so we have seen this particular stuff. Then we have seen the the React agent. React agent basically. So over here, that is something basically reasoning and action, and uh, based upon that particular reasoning, like we are going to take the actions, actions and all those particular things we have seen it during the tools only. During our sessions with the tools, we have seen the React agent as well. Then like once we were having we have created the tool, then the issue was with respect to the memory, memory piece. So if like the state of a particular outcome is not stored somewhere, so we will not be able to get the outcome. So what we have seen, stored the state in memory. Yeah. Okay, so the we have seen this particular piece as well. Then we have seen, say, if we are keeping a lot of things inside the memory, and then we are going to utilize those particular queries in order to get the answer from the large language model. So that is going to create the issue. So we have seen like how to filter the SMS. Sorry, not SMS, but the messages. Filter the messages. Say if we are having 10 messages, then we can say, I just want to get the output from last two. Okay, so that piece we have seen. Moving further, like filtration onto the messages, that is giving me an opportunity that, like with the help of this, like I was able to reduce the tokens, but somewhere I was losing the context. Okay, just give me a minute. Just give me a minute. Was creating the issues. So then we have done the summarization onto the messages. So summarization, we have seen summarization on messages. Okay, and then storing these or persisting this state, the state in database. Okay, these particular things we have seen in detail, and in our like previous 2 to 3 weeks was consumed onto this particular stuff. Okay, that is perfectly fine. Now we are going to start a particular project. Okay, and project, what it will be a rag basically. And what we are going to do, so we are going to design something, what I can say, C rag. uh, that is nothing but corrective rag. Corrective rag. Okay, so if you are having a particular rag solution, Okay, and that RAG solution is not going to provide you the correct output. How you are going to do the correction on top of that particular RAG, huh? So that's what we are going to learn, and we are going to implement it with the help of line graph, huh? Okay, line graph will be utilized in order to have this particular implementation. And before moving further, I just want to get the insights from your side. Like if the RAG is not going to provide me the correct output, okay, apart from the optimization techniques that we have seen, what else you can do? And you can start speaking at this moment, like how you are going to do this particular optimization, huh? Corrective RAG, huh? What do you understand with corrective RAG, huh? Guys, Nikhil, Vikas, Raj, Javed, Yogendra, Manish, Lakshmi, what do you understand with corrective RAG, huh? Is it out of the box, huh?
Maybe we can change some like some some maybe we can change something prompts or parameters
Hmm.
kind of.
Okay.
Related to
Uh,
any special retrievals which we can use over here just to increase the effectiveness.
okay. Okay. Let me like refine the query a little bit more. You can take it in this particular way. The knowledge base, okay, which is available. The answer is not there inside the knowledge base, and you want to provide the answer, huh? You can take it in this particular way. Like say your RAG is not having the answer of a particular question, huh? You can take it in this particular way. Say you have created uh, a RAG that is say based upon say some telecom data, and a user can ask the different questions with respect to the current scenario. Okay, and that information is not available inside the RAG, but still you don't want to degrade the performance, or degrade the quality of the RAG, or degrade the satisfaction of the users. So you are willing to improve it further. And I know you are having the answer of this particular question, but you need to start thinking in that direction. How
So
you are.
maybe we can make some mechanism where like our RAG or particular agents can automatically check what is the issue and try to resolve it based on
Mhm.
retrieval or vector database related or document related issues is there. They can
Mhm.
automatically find it and try it and take the steps to resolve that type of issues. If
That
that
is
mechanism
perfect.
can.
That is perfect one. What else?
In case of halogen.
If any answer is not available, then it
Mm-hmm.
may connect to the web word also.
You
Their
can
internal
connect with.
knowledge, their internal LLM knowledge.
But
सर
NLM is already there. Huh?
वेक्टर डेटाबेस से जो डेटा मिलेगा उसको इवेलुएट करना और उससे रिलेवेंट डेटा को फाइंड करना
Okay,
ऐसा
so
ऐसा कोई स्टेप ऐड करना पड़ेगा इसमें
okay,
जिससे
so
इससे करेक्ट डेटा लेकर और इनरिलेवेंट कॉन्टेक्स्ट को इनको निकाल दिया जाए फिल्टर आउट कर दिया जाए
hmm,
किसी
okay,
भी
so
रिस्पांस के पहले
so we are not able to get the correct chunks. Okay, if chunks are not relevant, then how I will be able to provide the output? And if say LLM is also not having that information.
You mean to say the information is available in the document which we are referring, but
No, no, no. Documents are not relevant. You can take it in this particular way. It was the telecom chatbot, and I'm asking the healthcare domain questions over there.
oh,
So it means the knowledge base is not utilized for me, and I
in
need
that
to.
case, we need to use some other knowledge base.
So that time drag can make some time of such type of mechanism that can add relatively correct LLM knowledge or internet knowledge to provide the correct answer.
Sir, in that case, like a React agent, we can pass this
Mhm.
information to other, uh, like an agent or other back chatbot,
Mhm.
which can search uh, in sense of globally with the available resource and analyze and observe. Because if our terms are not relevant and LLM don't have the relevant information, so we must please go outside our box.
Hmm. Mhm. Okay. So
आई थिंक
so.
सर स्कोरिंग करना पड़ेगा क्या चंक्स के चंक्स में
Or sir, we can define some supervisor type of agent
Mhm.
which can act like whatever the information asked based on information that can route to correct type of agent, like suppose that if information is asked about the telecom, then that supervisor agent can route that information to senior telecom engineer kind of agent that can act on that problem. If problem is asked related to medical domain, then that agent route that problem to senior medical engineer kind of agent. Maybe that it will work.
Hmm. Okay. So if I'm able to conclude whatever you have mentioned, so all of you are moving in the same direction, and that is appreciated as well. Okay, like uh, you are you have started the your thinking in that particular direction. You are having a view like how to design a solution where we need to enhance or improve the performance of our RAG solution. So whatever I'm going to discuss, that will be based upon the official documentation of the LangChain or LangGraph. Okay, I'm going to utilize that particular document and the the approach what they have suggested, and that is applicable to all the domains. So let me try to show you that particular piece. Okay, over here. Okay, so over here, if you are able to see self-reflective RAG with LangChain. So this is what we are going to understand. And over here, just have a look over here. Say if I'm having a particular question, so as we are going to implement it with the help of the line graph, so the circle what you are able to see over here are nothing but the nodes, and these arrows are nothing but the edges. Okay, and this is the conditional edge over here. Now the main piece what you are able to see over here, if the question is going to ask, it is going to like fetch the required documents from a retrieval node. Okay, once we will be having the documents from the retrieval node, then what it will do, it will do the grading on top of those particular documents. And like grading is done with respect to say yes or no. Okay, if based upon the grading, then what we will be able to get, like the documents which are graded from this particular graded node. So are these particular documents relevant in order to provide the answer? So over here, we are going to do that particular check. If it is relevant, then it is given to the generate node, and which is going to provide me the answer, final answer. If that particular, you can say, document is not relevant, then we are going to perform, we are moving to the rewrite the query node. Over here, what is being happening? Over here, what I'm going to do, okay, so I'm going to transform the query, rewrite the query basically, and perform the web search. Okay, once the web search is done, so particular documents up. So grading is done. Decide to generate like and post grading of these
Sir,
particular documents
sir, the screen is not visible.
with everyone.
Yes, sir, not visible.
Yeah, not visible, and your voice was also breaking in between.
Now it's good.
But I have shared the screen.
Visible now.
Uh-huh. Okay, so I was going through with this particular flow. Over here, I'm going to ask the question, then I will onto the retrieve node, I'm going to retrieve these particular documents. That is coming from the knowledge base. Okay, so once the documents are there, then these particular documents will be passed from the grading, you can say, node, which is going to provide the information. Say, is this particular document relevant or not? So if the document is relevant, then output is generated from those particular documents. And if it is not relevant, then what we are going to do, we are going to rewrite this particular query, transform the query. That is a node basically, and based upon the query, basically, we are going to perform the search onto the Tavily search. We are going to utilize basically over here, and it is going to fetch the documents from the internet. And once the documents are available, it and definitely these documents are fetched based upon the user query. So basically what we are having inside the
You're breaking in between.
uh, uh,
Voice is not clear.
let me change the internet connection.
सर ये एयरटेल का हर जगह इशू है.
Hello, hello, hello. Am I audible?
Yes, sir.
Yes,
Perfectly.
sir.
Okay, perfect. And are you able to see my screen?
No, no.
No.
Mhm. Let me reshare it. Is it visible now?
Yes, visible.
Okay. So what I have mentioned, I will be going to utilize this particular flow with respect to the corrective drag. Now, this is one way. What can be the another way? We are going to discuss this particular approach. That is perfectly fine. But what can be the another way in order to have the optimization on top of a particular RAG solution? What can be the another way?
So another way maybe ranking of documents based on query.
Hmm. Okay. So, mhm. Okay, you just need to focus on to this particular example, huh? Or rag with feedback. Good. Mhm. Mhm. Hmm. So over here, what we are trying to do, we are trying to do the optimization. Okay, or do the optimization on top of the RAG output. So over here we are checking, is it the relevant one, the chunk that we are getting uh, from the retrieval phase, and if that is relevant, it means like we are aligning large language model. Now it will be going to take the query and check the relevancy with respect to the outcome, and if it fails, this is the relevant one, so it will be given to the generate node, which is going to provide the outcome. And and if the outcome is not relevant, then it will be given to the rewrite query, and the query will be searched onto the internet, and then it will be given to the generate query. Okay, this is the flow that we are going to do. But in the normal, you can say, world, what is being happening, just have a look over here. So probably, so user query is given to the retriever, then we are having a certain prompt given to the LLM, then response is given. Okay, just have a look over here. So the response, just have a look over here. The response is given to the user. The response is given to the user, and probably you have seen the feedback mechanism. Say Are you uh, are you liking the output, or is it positive or negative? If at this moment over here as well, we will be able to see the feedback piece. Huh? Uh, okay, so this is nothing but like this image or dislike this image. Huh? This is nothing but the feedback loop. Huh? Over here, whatever is being generated from the large language model, and probably you have seen this onto the multiple chatbot. But how to implement this? What is the functionality over here? Do you have any idea? What is the functioning over here? What is the functionality over here? How the things are working? This feedback mechanism, huh? Like this image or dislike this image, and it will be on each and every answer. Huh? Say LLM context window. So probably yesterday I have asked this particular question. So over here, good response, bad response. What is this? This is nothing a feedback mechanism. Hmm? So how to design this particular solution? This is the another way. Improve the RAG responses. Can can you try, guys, like what is being happening over here based upon this particular feedback?
So basically, based on the feedback, we will be trying to improve the output.
Correct. This is perfectly fine, but how to implement this?
So if we dislike here, so it will rewrite our query again.
Is it rewriting? Incorrect or
Just
incomplete?
ask. Okay,
Submit. Is something happened over here?
I think.
Hmm?
Thing where if it is giving a like feedback, then it will continue the same way. If it is a dislike, then it will be give another answer.
No, no, it is not giving the answer at this moment. Huh? Nothing has been changed. It has just recorded the feedback.
Like so we will go with the normal reg solution first. Like we'll giving the query, then retrieving, then chunks will be retrieved, then we'll be giving the prompts. Maybe we can then it will go to LLM. Then we can maybe we can in between of this we can define some agent who can decide this answer is correct or not, and provide the feedback again to LLM. If answer is correct, then LLM may provide the final answer like to user. If answer is not correct, then maybe LLM can we can go with previous mechanism or optimization techniques like query rewrite, yeah, or re-ranking the documents. Then this mechanism will go infinitely.
Okay, so guys, don't try to confuse yourself. These things are pretty simple. Huh? Like if we have done the optimization and all, that is perfectly fine. Okay, and the optimization all that is done from the developer side. Huh? Okay, based it might be during the testing, during the benchmarking, or it might be based upon the user feedback. Huh? Say uh, I'm not able to get the correct answer, so you need to do something. Uh, but how he is able to get the input? How the developer will get the inputs from the users? So the the normal procedure is feedback, based upon the feedback. So on each and every chatbot, we are providing onto the UI itself. We are providing positive and negative like or dislike button. Based upon this, what is being happening? Say if I'm clicking onto the like, it will do an API call. So I'm going to create an API. Okay. So on UI, user interface basically, user will click on like or dislike. Dislike. At this moment, what will happen? One API call will trigger. Will trigger and and it will create an entry in DB. That is not the vector database. It is something say PostgreSQL or say DynamoDB. We are having the creation of an entry inside the database, and it can have the different things. Say username is there, session is there, question is there. Okay, I will pass the question, I will pass the answer. Okay, then feedback. Okay, feedback is there, and inside the username will be there, session, question, answer, feedback. It might be positive and negative. So these information will be recorded inside the database. These entries will be recorded inside the database. And over the period of time, say we are going to do the analysis onto these particular entry onto the monthly level. So we'll try to capture all of these particular data and try to identify like what has happened at that moment. It might be possible, say user has asked like, say what is Gen AI, what is Gen AI, and answer say blank information, or say error 404, such type of information was thrown onto the UI. So it might be possible like the token limit exceed. It might be possible the connectivity issue, because of that like user is not able to get the answer. So there might be a lot of regions, and with the help of this particular analysis, we will be able to get if like we are not having connectivity or hardware related problems, then we'll try to analyze the answer based upon the question. What is the missing over here? And if like we need to do the refinement onto the vector database, then we'll proceed with respect to that particular operation. Are you able to get what is being happening in the real world? Just try to
Correct,
think
sir.
a minute and ask if
Correct,
you
sir.
are having a doubt.
If GPT-3 is providing sometimes wrong answer, then we have observed after some time it will automatically correct.
So until and unless it is not having the information, that's why they have given this particular like dislike piece. If I'm disliking it, nothing is happening at this moment. Okay, but the record is moved inside the database somewhere, and after some time they will do the analysis, and then they will come with the solution.
I mean, instantly there is nothing happening, but it is taking the feedback and stored somewhere in database, right?
Yes, yes.
Yeah,
So
correct. Yeah.
that is first part, and the corrective reg, that is nothing but real time correction that we are going to learn.
Okay, so someone if intentionally making dislike again and again, that will misguide also.
That can misguide, but based upon analysis, they remove that particular piece, like it is not making a sense. Okay, they will not consider that particular output then, feedback, right? Making sense? Are you able to
Yes,
visualize what is being happening?
yes, yes.
Okay, so once you are going to design a particular RAG solution, don't miss the feedback piece as well. You need to think for the feedback mechanism. And let me try to uh, can you share the flowchart where I will be storing the feedback in a database. Also mention the important field and how to take actions on this data. Okay, so it is going to create, it will take some time, it will generate, and over here with the help of this particular image, what you are able to see, like feedback is given and the feedback is given to the user only, and feedback used to improve retrieval, rank, refine query, update index. So based upon these particular inputs only, you are going to apply those particular optimization techniques that you have seen. Huh? Are you able to correlate at this moment? Huh? You can't apply all the optimization techniques. You have learned about the optimization technique, but why you need to
Uh, sir, are they that means are they still also using the grading mechanism on the feedbacks also, like which feedback has to be taken or which feedback has to be discarded, ignored?
yeah, there will be a lot of analysis at that moment. Huh? You can take, just have a look over here. The feedback is captured, it is captured inside the database, and let me try to download this image and open this. Huh? And now it is mentioning the important fields as well, say feedback id, session id, user id, query response, retrieval chunks, how many chunks are there. Okay, so all of these particular informations are stored inside the database. Then analysis being happening, aggregate metrics, identify the issue, trend analysis, then segment, query type. Is it the like due to query, it is because of a category, it is of because of a model or the version, or it is based upon the time, right? So the analysis is being done onto this particular feedback, and if it might be possible the query is not correct, the user is willing to get the answer, is there life onto the Mars, so that information is not available, okay, we don't know like is there a life or not, okay, so at that moment, like it can be parked into the bogus question list. Okay, the question is not the correct one. So the analysis is being done, and based upon the analysis, like say the optimization techniques are applied, say re-rank, missing documents, update the embedding indexes, improve the LLMs, okay, improve LLM prompts and all, improve UX, track the impact and all. So different stuff we can do, but based upon what? Based upon the feedback only. You know this particular part, but how to trigger this particular part? It must be based upon certain feedback. We are connecting the dots. Huh? Are you able to visualize what is being happening over here? Yogendra, Nikhil, Manish, Lakshmi,
Course.
Vikas.
So what are the actions they are taking? So that action also we can use in our flow, right?
We
To
know about
retrieve.
these particular actions. Huh?
Yes, yes.
We know about these particular actions, but how to trigger these particular actions
Based on feedback.
based upon feedback, huh? And how to capture that particular feedback? This is the flow, correct?
Yes.
So you have seen this particular part, huh? Response and all the feedback, that piece we haven't discussed, but that piece is very simple. It is just an entry, and then we need to do the analysis, and based upon the analysis, like, we just need to take the corrective actions, huh? It might be possible, say, the embedding or the chunking that you have done, it is not correct, huh? You need to change the chunking strategy. It might be possible there are certain missing documents, huh? You need to embed those missing documents as well. It might be possible the LLM that you are using, it is not correct, or it is not meant to provide the outcome on top of the questions of your domain, huh? So you need to change the LLM. It might be possible the LLM parameter size is too less, and it is providing the less accurate answer. So you need to change the LLM as well, huh? Correct? Now, think for a minute and ask if you are having any doubt, huh? Is it fine with everyone?
Yes.
I want to hear from all of you. Is it fine with everyone?
Yes, sir.
Yes, sir. Yes.
Perfect. Huh? So this is the simple piece basically. You just need to connect the dots. Huh? You are having the information like what are the different optimization techniques to improve the output. But how did you get this information? You need to apply an optimization technique. It means you need to apply, because say the outcome is not correct, the outcome is not as per the user's expectations. So what you need to do, you need to identify, do the analysis onto that particular problem. Okay, and then you will come up with the solution, huh? And these particular things are done, uh, like you will ask the question, get the output by changing these particular optimization techniques, huh? Making sense? Making sense, guys?
Yes, sir.
Yes.
Yes, yes.
I'm not able to feel the energy.
Yes, sir.
Okay, not an issue, huh? Just just try to go through with these particular uh, snapshot that I'm going to share, and you will be able to get it. There's no rocket science, huh? You have gone through with a long journey, you will be able to understand. It is just you need to think in that direction, huh? Okay, let me come on to to the point, corrective rag. So this is happening based upon the data, collected data, and it is not in real time. We are capturing the feedback and do the analysis on that feedback, and based upon the analysis, we are going to take the actions, and then the actions can be anything. But if we want to take the corrective actions based upon the query only, and check the outcome onto the uh, internet, and provide the output from the internet, if the knowledge base what we are having is not enough, so then the corrective rag is coming into the picture. And this is the simple, you can say, flow diagram for the corrective rag, and we have discussed about it. Over here in this particular corrective rag, uh, if you are able to see, the example notebook is there, and if you are going to click onto the example notebook, you will see this particular GitHub repo link, and over here we will be having the information about this particular corrective rag. This is the flow that we are having. I will I will explain this particular piece. Okay, and like we'll start the implementation in our tomorrow's session. So we are just importing certain, you can say, libraries, say recursive text, character text splitter for the splitting, document loader, web-based loader to load the document from the internet, and vector chroma DB is the vector store. OpenAI embedding is utilized for the embedding piece. And we are passing the URL. We are, you can say, loading these particular documents, creating, performing the chunking, and then creating a vector store and retrieving these particular documents. This particular simple piece we have seen multiple time. We have implemented it multiple time. Correct? Guys, are you able to see this particular piece?
Yes, yes.
Loading, chunking, and vectorization. Embedding and vectorization. Okay, so we will be having the retriever. So I will share this particular piece. You can go through with this particular code, this particular uh, architecture what we have discussed, and in tomorrow's session we will be having the implementation of this particular code. Okay, this is very simple, and what you need to do before coming to the session, you just need to create the Tavily API key, OpenAI API key we are having, and for Tavily API key, onto the Tavily you can go onto this particular website, and then you need to sign up. Logging in. So I have created my account over here previously, and probably this was the ID what I have used for Tavily account creation. And just have a look. This is the API key what I have created. Okay. So in the same fashion, you just need to create the Tavily API key, and that API key we are going to utilize in order to perform this particular corrective rag operation. Okay. So practically we'll start in our tomorrow's session. I just want to give you an overview, like what will be the architecture of this particular corrective rag, or what will be the flow diagram. And I just want to discuss about the feedback mechanism. And I have gone through with that particular piece. And in tomorrow's session, we will be having the discussion on to the implementation part, because I'm thinking you all are having a little bit low energy today, and I don't know like what has happened with you all.
It is just because of the
Yeah,
timing, I guess.
The timing it's a timing of पुरानी वो 26 तारीख की और 1-2 तारीख से रिकॉर्डिंग नहीं है सर.
I have shared it, but let me reshare it in this particular. Let me stop the recording first.